Okay, so we're going to solve this Bernoulli equation y prime equals y times 2 minus y. And this initial value problem, we have initial value y of 0 equals 1. So the first thing we want to do is just verify that it actually is Bernoulli. So the generic Bernoulli form is y prime plus p times y equals g times y to some power n. And this is really the part that makes it Bernoulli, the y to the n. So that makes it nonlinear if n is bigger than 1. All right, so let's just rearrange this equation and see if we can make it look like this one. So we'll get rid of the parentheses. So it'll be 2y minus y squared. And then I'm just going to move the 2y to the left. So that leaves me with y prime minus 2y equals negative y squared. So, here P is equal to negative 2, G is equal to negative 1, and N is 2. So that's, this is Bernoulli. So the way to solve a Bernoulli equation is we're going to make a substitution, and that substitution will turn it into a linear equation. So it's nonlinear currently because of the y squared. We're going to make it linear by making the substitution. And the substitution you make is always, we like to use the variable v. V equals y to the 1 minus n. So y to the 1 minus n power is v. So in our case, n is 2. So v is y to the 1 minus 2. That'd be negative 1. Or you could say that's 1 over y, y to the negative 1. So we want to make this substitution, but we need to figure out y prime. So we have y here. We know that y would have to be 1 over v, right? And we could find y squared pretty easily if we needed to, but we need y prime. The way we could do that is to find the derivative of v. And, we're using an independent variable here that's not seen. So y is some function. We're going to use the variable t. Y is some function of t. You could use x. Doesn't matter. We're going to use t in this problem. That means v is also a function of t. Okay. So when we take the derivative, we're actually taking the derivative with respect to t. So that means we have to do implicit differentiation here, which basically just means you're using the chain rule. Okay. So we're going to find the derivative of y to the negative 1 as if we're taking the derivative with respect to y. So that's just a power rule, right? So that'd be negative y to the negative 2. And then we multiply by the derivative of y with respect to t. We'll just call that y prime. Okay. So we could make the substitution of y prime by just solving this for y prime. So we could just multiply both sides by negative y squared, and that would get rid of this. So we would get negative v prime y squared is y prime. All right, so I like to substitute after I divide both sides by y squared. So whatever your y to the n is, go ahead and divide both sides by that once you get this Bernoulli form. So that would give us, if I divide this by y squared, I get negative 1. And on the other side, I get y prime over y squared. And then this would be minus 2 over y. One of the y's would cancel from the y squared. Okay. And now I'm ready to make my substitution. I'm going to substitute y prime as negative v prime y squared. And then 1 over y is just v. So I've got 2 times 1 over y here. So it's just going to be 2v. And then these y squareds are going to cancel out. So now let's just multiply both sides by -1, and we get v prime plus 2v equals 1. And now it's a very simple linear equation that we can solve using our methods from earlier. So we're going to use the integrating factor, right? So the integrating factor would be e to the 2t. So we're using t as our independent variable, but you could use x, like I said. We're going to multiply both sides by that. So e to the 2t v prime plus 2 e to the 2t v equals e to the 2t. And you just verify that you have the product rule for derivative form here. So this is the derivative of e to the 2t, so we're good there. So we're going to reverse the product rule. So we get e to the 2t v prime equals e to the 2t. And antiderivative of both sides. So that would be 1/2 e to the 2t plus c. And then let's multiply by e to the negative 2t on both sides. That would give me 1/2 plus c e to the negative 2t. So we've solved it for v, but we really want y, right? Because we had to make that substitution. So let's substitute y to the 1 minus n back in for v. So that was y to the -1. That would mean let's take the reciprocal of both sides. So we just do 1 over this whole thing. Right, now, still not done because we have this initial value, y of 0 equals 1, so we're going to solve for c. So I'm going to plug in 0 for t. I'm going to plug in 1 for y. If I plug in 0 for t, that's e to the 0, that's 1, so I just have a c right here. Right, so I just need to solve for c, so let's multiply both sides by 1/2 plus c. And then subtract 1/2. 1 minus 1/2 is 1/2. So I get c is 1/2. I'll plug that back in to my equation. And let's just make this look a little bit nicer. Let's multiply top and bottom by 2. So let's multiply by 2 over 2. So I get 2 over 1 plus e to the negative 2t.